Hey, so why didn't you guys tell me that my image was called img_3894.jpg? In the last video, I was talking about not renaming your image, batch renaming, and here I am with an image that's named by the camera. Woo, that's a bad. Okay, anyway, it does give me an opportunity to actually show you something really convenient in Bridge when you're renaming a single image. If you just click on the name right here, you'll notice that it gives me a field that's highlighted that excludes the file extension .jpg. This is really important, and actually it's a really great function that it does this automatically. If you eliminate JPEG as a file extension, especially on a PC, your computer could have trouble recognizing what type of image this is. It might think it's a Word document, it might think it's a QuickTime video, an iTunes, MP3, who knows. So it's that JPG which indicates to a PC that it will open it up in image viewing software. So don't get rid of that. I see people highlight the whole thing and wipe the whole thing out. Big mistake. So once you, oops, let me click off and on it again. Okay, here we go. There we go. Okay, and then I could just type in scoop. There she is, scoop JPEG. Okay, so now I'm going to open this image with Photoshop, and notice I go through the menu or I drag it into the Photoshop icon as opposed to just double clicking on the image. That guarantees that I know what software I'm opening up in here. So now I want to work on changing the image size. Remember, we're going to send this image on the web, and so down here this is a quick view of how big my image is, and it says 22.8 megabytes. No way am I going to send that to everybody I know. They will hate me. So I need to bring this down to under 1 megabyte so I can send it. So I'm going to go into, and by the way, the size that we're looking at right now has nothing to do with what the print size is. So whatever you see on your screen, you can't really trust it. That's really just for viewing. You know, like if someone has a really small TV, someone really has a big TV, does that make the people smaller or bigger? No. And so in this case, when I view this image like this small, that's not how big the print's going to be. That's literally my viewing mode, so the scale that I'm looking at. And what indicates this on the image is right up here on the top. See how it says scoop JPEG, and I'm looking at her at 2.39%. So in other words, that's the scale of the original image. I'm only looking at 2% of that. So the only way to have a true indicator of what the size of the image is to go under image up here in the top menu, image size, and this is pretty intuitive, like it makes sense. The image size is under image. So we open image size, and this tells us that our image is 14.4 in width by a height of 9.6. So this viewing of large to small on the screen, check this out. This is how she's going to be when she's older. She's going to bite my head off. I know it. Let's see those teeth. Nothing there yet. Okay. So anyway, notice also that I'm zooming in and out without using any of the toolbar here. And this is a nice little trick I want to mention, is if you go into Photoshop, and we usually try and set this in the classroom as a preference already, but if it's not working on your computer, go into Photoshop Preferences, General, and there's a checkbox right here that says Zoom with Scroll Wheel. And so what's great is I'm just using the scroll wheel to zoom her in and out. And so I'm just doing that by pushing the little scroll wheel. It used to be a lot harder to navigate around your picture, but that makes it really easy. So, okay. I'm going to resize scoop for the web. So I want to take a look at image size. And first of all, the resolution is at 240. And for the web, I only need something like 72 pixels per inch. So let's talk about that for a second. What does that mean, pixels per inch? it is not an abstract thought. It's actually really concrete. Imagine an inch of the picture, and in each inch there's 240 pixels. So actually, let's cancel that and let's take a look at it. I'm going to zoom in on her as much as I can, and hopefully, let me get to a spot where maybe you could see this a little better. Let me go on her eye. Okay, are you seeing the pixels there? In each inch, there's 240 of these little squares. 1, 2, 3, 4. And so the difference between having an image that's 72 pixels per inch as opposed to 240 pixels per inch is that in that same inch, I have to squeeze in 240 pixels. So by that account, those pixels have to be smaller in size than if I have a 1-inch area with 72 pixels per inch. So it's really logical, like the lower the PPI of your image, that's the resolution on that chart, the lower it is, the bigger the pixels are going to be and therefore more visible. So if you had let's say you went to image size and you typed in a resolution of 1. I wouldn't necessarily do that, but let's say I typed in 1. Then I'm going to have 1 pixel that fills a full inch. I'll have just like 1 pixel per inch. So that would be, it would probably pretty much render the image impossible to decipher. So you don't want a 1 pixel per inch image, but just, I think a lot of people get confused about this, and it's actually easier than you think. It's pretty literal. Okay, so now let's talk about image sizing, which isn't that straightforward. This palette has kind of an upstairs downstairs. So as you can see, we've got pixel dimensions upstairs and document size in the downstairs. And what's going on here is that the upstairs is telling us literally how many pixels are running across the width of this picture. So in other words, 3,456 pixels, I could actually go and count 1, 2, 3, 4, 5, all the way up to 3,456, all the way across. And up and down, if I counted a row, I get 2,304 pixels. So this is literally how many pixels, not per inch, but per image, are running either by the width or the height. So when I go to these boxes right here, and this is kind of our main issue, resampling the image. This is a territory, this is a little checkbox of much controversy. What does this thing do? For one thing, when I uncheck resample, notice this little diagram right here. This links everything together. So in other words, my width, my height, and how big those pixels are per inch. What this does is it keeps you honest. And this is really important. In other words, what went on the sensor, what was laid down, actually, it's actual pixels. So when you change your image size, then the pixels don't change. So let me give you an example. If I double the width of my image, let's say I go to 29, I'll go to 29 inches. Notice that up here in the upstairs, the width doesn't change. 3,456 pixels. So no change in the pixel dimensions whatsoever. So no pixels are shuffled around. What did change is down here, and this is the key. I went from a resolution of 240 pixels per inch to a resolution of 119 roughly. And so basically it cut my resolution in half. It cut my image quality in half, but I gained scale of the image. So this is what would happen if I stayed truthful, kept my image whatever pixel dimension it was in the beginning. Now, let me show you the opposite of that. I'm going to reset this image, holding down Option, hit the cancel button. And this time I'm going to not link them all together like I did the first time. This time I'm going to click on what's called resampling your image. What happens here is that it unlinks the height and width from the actual resolution of the picture. Lots of times when I talk about this resample button, I call it the lying button. Like when you click that, the minute you click that box, you are a liar. You're a liar right there. Now, in the books, they're not going to say you're a liar. What they're going to say is that you're interpolating the image. You're using interpolation. And what that means is that you're actually creating an image that has made up images. And that's why I call it lying, because it really is. It's made up. So let me show you the example of that. This time, with resample checked, I'm going to go to 29 inches again here. And notice at the very top here, my width went from 3,456 to 6,960 pixels. So in other words, when there was like 3,000 across, now I'm going to 6,000 across. Where did those come from? Were they there all along? No. What happened is the computer is taking each of these pixels and saying, okay, the nearest neighbor, so like this one right here, I'm going to make up another one that looks just like it, and another one that just looks like the one next to that. That's what interpolation is. So if I say okay to this, whoop, I doubled the size of Scoop, but all those pixels were made up. So that is what's called interpolation. There it is. Interpolation. So, you know, I don't see any problem with the image, but if you were going to print really big, you might start to actually see problems within the image if you're interpolating, where you would, like let's say right between here and here, between the pink and the blue of her eye, suddenly if the computer's making up an interpolation of nearest neighbor, it could make a mistake, and it will make a mistake. So interpolation isn't all bad, but you do want to be careful about how far you push that. So that's really important. Okay, so now let's go back to our image size chart. And we know now that if we double the size of the image, and I went back to where we were before, we're going to actually double our pixel dimensions. And that's by lying, by checking that resample box. The minute you free the resolution, you can actually start to change how many pixels are in your image, and that's the bottom line. Now in our case, we actually want to do what's called interpolating down, which isn't the worst thing in the world. In other words, we're not making up pixels. The computer is going to interpolate and throw out pixels. So this is too big of an image. It's 22 megabytes. So we want to knock down our resolution to 72 here. So I'm lowering the resolution, and see, in lifetime it's actually telling me, okay, I lowered it to a 2.05 megabyte image, and it says here, and it was 22. So just by cutting down my resolution, that made a huge difference. But now I don't need to send people an image that's 14.4 by 9.6. So that brings me to the next thing, which is this little checkbox right here, constrain proportions. Right now I've got the height and the width linked. So if I put in, let's say, what did I have, 29, notice that my height changes right along with it. So the image will stay in proportion, in the proportion that I shot it. But let me reset that, and if I change this without constraint proportions checked, and now let me do something radical, change it to like 60. Notice that my height didn't change at all. It's exactly the same. When I click OK, look at what happened to poor Scoop. she looks like a bat now, or like a pancake. It's a cat pancake. Okay, so anyway, you know, people do this not so radically, so they don't even notice. They'll do something subtle, and they'll make people's, either their head is stretching up or their face is stretching out. You don't want to do that with a portrait. So Scoop won't know here. So I'm going to go back. Whoop. Hey, that's kind of funny. Okay. So if I go back to my image size, it is crucial that I constrain the proportions. I never have that one unchecked. And then I got to make a choice here. Do I need to resample my image down smaller? If I resample up, do I really want to interpolate that much? So in this case, I'm going to go with 72 for my resolution, and I still want to make that smaller. So at this point, I want to resample. I know that I'm interpolating. I know what's going on. And I'm going to make my image with 7 inches by 4 inches. That's more reasonable. And notice way up here, now my image is half a megabyte, 496K. So fine for sending on the internet. Could even go smaller. And then there's one more interesting thing I want to mention is down here, there's a little pull down menu, and it actually has a cheat sheet next to it, which I think is very nice of them. And it tells you which is the best one for either enlarging your image or reducing the image. And what this does is it chooses the nearest neighbor, and it's working sharper. So in other words, it's going to sharpen the image a little bit, which is what you need when you're reducing your image. So I'm going to go by cubic sharper. Click OK. And there she is. Now remember, that's not the actual size. My image size is 7 by 4.5, 72 ppi. And now I'm ready to send Scoop out in the world. And you can see the difference in pixels. Like if I actually blow this up, can you see, as before when we zoomed in, you couldn't really see how visible the pixels are, and now it's much clearer, right? I think you guys can see that. So thanks, Scoop, for the help.